To avoid unpleasant surprises, when the statement comes, you try to record all your credit card transactions in a ledger. Unfortunately, you tend to neglect recording about 5% of your purchases. Suppose that last month you had 25 purchases on your credit card account. When the statement arrives, you count the number of purchases you forgot to record. The random variable x represents the number of unrecorded purchases in a month with 25 transactions. Explain why this is a binomial experiment. So again, we have 4 conditions we need to meet. So let's go through those. So first thing we have here is we have a fixed number of trials. In this case, we have 25. We have independent trials. So whether we record a transaction or not does not depend on recording another transaction. The probability is the same for each trial. In this case, our probability here. And then lastly, we have 2 outcomes. So we either record or not. So again, make sure you check for those 4 criteria to see if we have a binomial experiment. So now we're going to find and interpret the mean. So again, here our mean is going to be n times p. So n is 25 and p is 0.05. And do that there, we get 1.25. So let's double check. Oops, 120. Right, so we want to now interpret that. So what we can say is this is, just in layman's terms here, real short and simple, this is the expected number of transactions unreported. So now we're going to compute the standard deviation. So again, we have a formula here. So our standard deviation, so sigma sub x, since we're dealing with a random variable there, is the square root of n times p times 1 minus p. So this is going to be equal to square root of 25 times 0.05 times 1 minus 0.05. So let's do that. So second x squared to give us a square root, 25 parenthesis 0.05 close parenthesis, open another one, 1 minus 0.05 and close our parenthesis. So we get approximately 1.0897 there. So the next question asks, find the probability that you would record all 25 purchases. So here we want to be really careful. Let's think about what our problem says. So let's go back and highlight here. So it says we tend to neglect recording about 5% of our purchases. We have 25 purchases, and X represents the number of unrecorded purchases. So we're talking about recording all 25 purchases. So let's write our notation out. So we're talking about recording all 25. That means that we unrecord 0. Right? So that is the probability that X is equal to 0. Right? So there's 2 different ways to do this, so we'll go over the long way and we'll go through this the short way. So one thing we can do is use the formula, and another we can do is use some pre-programmed functions in a calculator. So let's first start with the formula. So we have my formula up here, the probability of x is NCX times p to the x times 1 minus p to the n minus x. So pretty complicated there. So this should look familiar. So we're talking about the number of ways to choose something times the probability of success, and then our probability of failures there. So in this case, our n is 25, and then cx is 0, and then our probability of success is 0.05, and we have 0 of those. And then 1 minus here, and then 25 minus 0. So we kind of shorten this out here, and we kind of break it in pieces. So if we do 25, math, go to PRB, number 3, 0. So that's the number of ways that we could record all 25 purchases, and then 0.05 to the 0. We get 1 for that as well. And then lastly here, if we do 1 minus 0.05 raised to the 25 minus 0 is just 25. This here, so I'm going to say 4. Change it to approximately equal to. So we get approximately equal to 0.2774. So you can see that's a little bit tedious there. So there is a formula in the calculator we can use, or a function rather, called binomial PDF. So when you're working with just looking for a distinct value, we have what we call a probability density function. So what I can do is do binomial PDF. So we're going to do second var, so it's kind of above it says distribution, and then you'll scroll down in your list. I'm actually going to go up because I will find it quicker. There's a binomial PDF and CDF, so you want to click on PDF when you're looking for the probability that x is equal to a specific value. So I'm going to click on that. It takes 3 parameters here, and they go in alphabetical order. So it's going to be binomial PDF and then NPX. So we're going to do 25.05 and then 0. So we'll do 25, comma, oops. .05, comma, 0, and then enter there, and you'll notice I get the same answer there. Right, so that's the shorter way to do that, and I would highly recommend doing that instead of using the formula. It's going to make things a lot easier. So if you have one of the calculators that has the menu, it's a little bit different, and I will go over that. So if your calculator has a menu, so you clicked on binomial PDF and a menu popped up, so it will look a little bit different. When you do that, I think it says like number of trials, no, maybe not. So it may say like number of trials and then success and then X or something like that. So just type in the appropriate things there and then click calculate. So next one we want exactly 4 purchases. So exactly, that's going to be the probability that X is equal to 4. So we're going to use our binomial PDF. So we use PDF when we're looking for X equals a value. So again, N, P, and then X is going to be 4 in this case. So I'm going to do second enter to pull up what I just typed in, and then go over and then press the number 4 and press enter. So this is approximately 0.02 And then we want to know, would it be unusual to find 4 unrecorded purchases in a month with 25 purchases? So yes, since the probability that x equals 4 is less than 0.05. Right? So now we want to know the probability that fewer than 4 purchases would have been unreported. So it's going to change a little here. So we want the probability that x is less than 4. So since we're talking about discrete values here, that's where we're looking at the probability that x is either equal to 0 or x equals 1 or x equals 2 or x equals 3, right? So we can add all this up together, right? All the way up to 3, right? So we can go through and do binomial PDFs of those, but we have a CDF. So what this CDF in the calculator does is called cumulative density function. So what that'll do is it'll add everything up into a certain value. So if you think about like cumulative GPA, cumulative relative frequency, all of those cumulative terms we've talked about before, same idea here. So the thing about the cumulative density function in the calculator is you want to convert everything to a less than or equal to statement to use that. So you can kind of see by us rewriting this out now that we have the probability that x is less than or equal to 3, and that helps us out because what that'll do is that it calculates everything up until that value. So I'm going to use binomial CDF and then the same parameters, NPX. So 25.05 and then 3. So that'll calculate 0, 1, 2, and 3 for me. So let's do that. So second vars, and then we're going to go to binomial CDF this time because I want multiple values. So anytime you want multiple values, you're going to use CDF. So 25, 0.05, 3. So this is approximately equal to 0.9659. So I could have went through and added up the PDF for 0 and 1 and 2 and 3, but this is the easier way to do that. And so the last one, we want at least 4 purchases. So this is the probability that x is greater than or equal to 4. So again, we have to rewrite this so that we're working with a less than or equal to statement. So if we write this as a complement, this is 1 minus the probability that x is less than 4. But if x is less than 4, that's the same thing as saying x is less than or equal to 3. So now I can do 1 minus binomial CDF 25, 0.05, 3 to calculate that value. And I just did that earlier, so I'm just going to do 1 minus second answer. So we get 0.0341 is our answer there.